Right now, due to the COVID-19 pandemic, e-learning technologies are way more important than ever before. And with anything that's this important, improvements can be done in the way we design and build the systems. With this in mind, we propose CARLA, a conversational agent in virtual reality with analytics. My name is Pablo Isaac Macias Huerta, and I'll get you today through the process of building this system. I'm going to show you the technologies we used, why they were used, the way they are implemented, as well as how they perform in real-world scenarios. First, right now, e-learning is very clunky. Most systems were just not designed to handle the amount of people that need them nowadays because of the special situation we're in. And most of them use conventional ways of teaching, such as the Blackboard method, or use non-interactable media, like videos or images. However, VR technologies are getting better and better every single day, and let the user be immersed in a contextualized environment that could be better for teaching real-world problems using a virtual world. But even VR-based learning technologies are not natural enough to interact with, using conventional computer inputs like mouse and keyboard. But there are many more ways to input something into a computer, and many more natural ways too, such as voice. And considering voice-based input is the best it has ever been, combining these two technologies seemed like the best decision for a system like CARLA. Now we had an idea, but we needed to use something that could allow us to create the virtual reality environment and could also support the chatbot implementation. For that, we chose Unity 3D, a game engine that, apart from handling set tasks no problem, also presents us with multiple advantages over other engines, such as it being free, compatible with multiple operating systems, and being super beginner friendly, allowing future team members to get up and running in no time. Then, we needed to create the actual conversational agent, but for that we first needed to understand what made a conversational agent. As it turns out, it's usually made from three main parts: natural language understanding, or NLU, dialogue manager, and natural language generation, or NLG. The NLU takes what the user said as an input and attempts to extract an intent from it. An intent is basically what the user wants the system to do. After that, the dialogue manager takes that intent and, by different methods such as hard-coded intents or machine learning, chooses an appropriate answer for the user. The NLG then processes the answer and synthesizes speech as an answer back to the user. For the NLU, we chose a combination of Google Speech's speech-to-text API and Stanford Kernel P's language analyzing tools. The speech-to-text API is a web-based service that lets us feed it an audio file, process it, and get a JSON file that contains the user's utterance as an output. Stanford Kernel P, on the other hand, is a Java-based natural language processing toolkit. However, Unity 3D runs on C#, so we needed a way to make Java and C# code interact. Now, luckily for us, someone had already developed a tool for this. Sergey Tihon made a .NET port of Stanford Kernel P. Now, as far as I understand, it works by communicating with IKVM, a .NET and Mono implementation of Java, which in turn interacts directly with Unity's C# code. For the dialogue manager, at least for now, we chose to go with hard-coded intents because of the limited amounts of valid intents available, all of them are shown on screen right now. The plan, however, is to implement machine learning algorithms to expand the dialogue manager. And finally, for the analogy, we went for Microsoft Azure's text-to-speech SDK, which is also a web-based service that lets us give it a string of text, and it will synthesize it into an audio file. Here's the whole system architecture, including the VR environment. On the right-hand side, we see the chatbot components. From top to bottom, we have the NLU, the dialogue manager, and the NLG. Now, if we focus a bit on the NLU, we can see four main processes. First, it listens to the user and parses his utterance into text using Google Speech. Then, using Stanford Kernel P, we tokenize it, separating the sentence into tokens, which in this case would be words. So now we have what the user said separated word by word. However, analyzing every single word would be a lot of unnecessary processing, as not everything the user says will be important for our purposes. For that, we do a parts of speech analysis to identify every word with its part of speech. Now, we know the lexical item of every word in the sentence, like a noun, proper noun, or verb. Now, using this data, we are able to filter words we don't need and only end up with the main parts of the sentence, the ones we will actually need and use for our purposes. As mentioned, the output is fed into the dialog manager, which chooses an appropriate response, which is then synthesized into speech by Microsoft Azure. Now, with a completed conversational agent, we needed a platform that the system could be implemented in. So we decided to develop a platform for power system education. The environment we developed has three types of scenes. Welcome scenes, or menus, that let the user navigate the system. Then, we also have facility navigation scenes that allow you to navigate recreations of real-world environments, contextualizing the knowledge. And we also have equipment understanding scenes that explain to the user what every equipment does, as well as lets them manipulate 3D models of them. Although CARLA was originally only implemented to operate in these types of scenes, it has now been expanded to operate from every single scene in the environment. After all that, we wanted to test how good our system was, so we tested the intent recognition performance. Every utterance will fall into one of these four categories. True positive, or TP, is a valid intent recognized correctly. A false positive, or FP, is an invalid intent that's detected as valid by the system. A false negative, or FN, is a valid intent that the system doesn't recognize. And a true negative, or TN, is an invalid intent recognized as such. For test, we had 5 test subjects, 2 women and 3 men, averaging 37.4 years of age. Each subject was given the same 40 sentences, 10 of which were invalid but contained similar sounds, letter combinations, or meaning than valid intents. Now here are the results for our 200 samples. We have 140 true positives, 44 true negatives, 12 false positives, and 4 false negatives. Now, using the accuracy formula shown above, we get a 92% accuracy for the system, which is fairly robust for a 1.0.0 version of it. Finally, in this work, we proposed CARLA, a whole educational platform that grants access to a conversational agent, recreations of real facilities, and equipment understanding sections. Now, as far as accuracy goes, 92% is fairly good for our needs, but we plan to expand it and improve it by using machine learning. Now, I have a bit of a demo for you today of the system in action. Let me load it. Now, I apologize, the system is in Spanish, so I will be talking to the system in Spanish. So here is the main menu. We can see CARLA on the right-hand side, just awaiting for orders. From here, we can go to another microgrid menu or to a stylized recreation of a real substation. So if we now go to the substation and listen.
Bienvenido a la subestación. Para correr, pulse Shift. Para preguntarme algo, pulse C. Para regresar, pulse Q.
We can see that CARLA talks to us and gives us instructions. And we can go around this world, we can explore it, and we can also interact with CARLA. For example, we can say, ¿Qué es un panel solar? She will process this and answer back.
Verás, los módulos fotovoltaicos o paneles solares son dispositivos que se utilizan para capturar la energía de la luz.
So she answers exactly what I told her to answer me. So, if we go back, she will explain the menu back for us.
Hola, y bienvenido al programa educativo de instrucción en sistemas de potencia. Yo soy Carla y seré tu guía. Desde aquí puedes acceder a un menú de microred o navegar una versión estilizada de una subestación, así como hacerme preguntas pulsando C.
Now we can go to the microgrid menu.
Bienvenido a la microred. Desde aquí puede acceder a un catálogo con el equipo, en el cual podrá interactuar conmigo vía voz, navegar una versión completa de la microred, o hacerme preguntas pulsando C.
Here we have the equipment understanding scenes and facility navigation. Let's go to facility navigation first. As you can see, here there is a completely fully fledged system that we can navigate of a microgrid. There's even a little tutorial for us to understand how the system works. If we get close to some of the equipment, it would also show us a little explanation of what they do. Here is a really cool part. Here is the solar panel power generation, and this is actually operating in real time. So for example, if I choose to control the time speed and choose it to go real fast, so it becomes nighttime faster, we can see that when we're at night, they should stop at a minute. There you go. It stops generating electricity because there's no sun available. And also we can control the wind speed, so we can see it works and it interacts with the system. And we also can go into like creative mode and actually navigate the whole system. The clouds actually affect the sun rays that affect the power generation. So it's a very, very complete system. And we can also interact with Carla from here, from any scene actually.
Bienvenido a la microred.
And
Desde
finally,
aquí puede acceder a un...
if we go here, I input my name. This is for a customized experience user for user.
Hola, Pablo, yo soy Carla. Bienvenido.
Here we can interact with Carla and the 3D models via clicks if talking is not available for some reason. Maybe it's a very noisy place. Or we can interact via voice. So for example, ¿qué es un banco de baterías? She'll process it and answer back.
Verás, Pablo, es un dispositivo que consiste en una o más celdas electroquímicas que pueden convertir la energía química almacenada en corriente eléctrica.
And the model appears here, like it should. And for example, we can tell Carla, acercamiento máximo. And it will zoom in for us, or we can say, rota a la derecha. And it will start rotating. So, this
Bienvenido a la microred. Desde aquí puede acceder a un catálogo con el equipo, en el cual podrá...
It has been an honor being here with you today, and I can't wait to be here again with you soon. Goodbye.